Addressing the rising cost of electric vehicle batteries. Subscribe to Electric Vehicle News Bitesize podcast for free. Electric vehicle costs are currently on a roller coaster. While the rollout of the technology is a key part of the government's transport decarbonization strategy, it slashed incentives in December by slashing funding for plug-in cars and changing eligibility criteria for the scheme. Some automakers have responded by lowering the selling price of their pure electric vehicles so they can continue to qualify, in part because the cost of making batteries, which account for about 40% of battery electric vehicle manufacturing costs, has dropped to record lows. However, rising gas prices have pushed up electricity prices as fossil fuels are used to generate 40% of Britain's electricity, while many experts predict battery costs will rise in 2022. We've got an ever-increasing reliance upon elements such as nickel, cobalt, lithium, manganese and copper for electric vehicle batteries, says James Nicholson, partner in advanced manufacturing and mobility at A. For a while now, a lot of those commodities have had suppressed prices, and there's a strong chance that, as demand goes up and these metals become quite scarce, we will see some of those material prices continue to lift. That's going to put a pinch point on the cost of the materials that go into battery cells, and that could lift the price to the carmaker and, eventually, the consumer. Inflation-adjusted prices for car battery packs were $1,200, £885 per kilowatt-hour in 2010, according to data from Bloomberg New Energy Finance. That figure dropped to $132, £97 last year. The impact on the manufacturing cost of electric vehicles is huge. Assuming a kilowatt-hour price of $132, it costs $6,000, £4,425, to produce a 50 kilowatt-hour battery last year. In 2010, that would be $60,000, £44,247. However, prices for many elements used in electric vehicle battery production rose sharply in the second half of 2021. For example, battery-grade lithium carbonate rose to a record high of $41,060, £30,280 a ton, an increase of more than 5 times the price of cobalt in January last year. Prices doubled to $70,208, £51,775, while nickel rose 15% to $20,045, £14,782 a ton. This creates a tough environment for automakers, particularly those in Europe, which have to increase electric vehicle sales in order to meet average fleet emissions standards, says James Frith, head of energy storage research at Bloomberg New Energy Finance. These automakers may now have a choice between reducing their margins or passing costs on, at the risk of putting consumers off purchasing an electric vehicle. Factors behind the increase in costs include investment in new mining and processing facilities to produce more material and increase demand. According to S&P Global Market Intelligence, lithium carbonate-equivalent supply is expected to increase to 636,000 tons by 2022, up from 497,000 tons last year. However, demand is expected to reach 641,000 tons. We're entering a new era in terms of lithium pricing over the next few years because the demand will be so strong, adds Gavin Montgomery, Research Director for Battery Raw Materials at Wood Mackenzie. The need to reduce battery costs is one of the driving forces behind the research. One way to achieve this is to change the battery chemistry to use cheaper, more common metals. For example, cobalt can be replaced with nickel, which is cheaper and contains more energy. However, cobalt has the advantage of not overheating and catching fire. The real breakthrough research will be to keep the cost down and retain the resilience of the supply chain at the same time, says Pam Thomas, CEO of battery research program the Faraday Institution, which oversees a consortium of more than 20 UK universities and 50 businesses. So it's quite a conundrum. You may find that you have different batteries in different cars. High-performance cars like McLaren's will use different batteries compared with city cars. We've got to get the right battery in the right application. Understandably, when news about new developments in battery technology breaks, the focus is usually on how much power the battery can hold and how long it takes to charge, as these are concerns for fleets and drivers right now. Addressing the rising cost. Announced last month, a team at the University of Michigan has developed a biomimetic membrane that could increase the charging capacity of electric vehicle batteries by 5 times. Another announcement was made recently by Israeli battery technology company StoreDot, which unveiled a patented technology that will allow batteries to regenerate during use. This self-healing system includes a series of software algorithms that can identify underperforming or overheating cells or battery strings and temporarily disable them, proactively restoring them to 100% with no performance penalty to the driver. According to StoreDot, the technology will play a major role in extending battery life and range, as well as improving safety by helping prevent overheating. The self-healing technology goes hand in hand with the company's development in extremely fast-charging lithium-ion batteries. Units expected to be delivered by 2024 could reduce charging time by 50% at the same cost as current batteries. StoreDot is also working on lithium-ion batteries that can be recharged in 5 minutes, as well as next-generation solid-state batteries scheduled for mass production in 2028. However, the focus is increasingly shifting to cheaper technologies that use fewer rare metals. One solution automakers are considering is to use an inexpensive lithium iron phosphate, known as LFP, chemistry as the cathode material. These batteries are much cheaper than industry-standard lithium-ion batteries, do not require nickel or cobalt, and are more stable, which makes them safer. However, these batteries have a lower energy density, which means they offer less range than other batteries of the same weight. The cold can also affect them more. In October, Tesla announced that it would use the LFP chemistry, rather than nickel-cobalt-aluminum, in its standard-range battery electric vehicles, which it will continue to use in its long-range cars. In its Model 3, the LFP will result in a small reduction in range to 305 miles. The move is seen as a way for Tesla to boost profit margins on cars without raising retail prices. It already produces cars using lithium iron phosphate batteries in Shanghai and sells them in China, Asia Pacific, and Europe. Ford and Volkswagen have also expressed interest in the technology for lower-priced models, according to Guidehouse Insights. Other manufacturers will no doubt follow. Toyota is sourcing LFP technology from Chinese automaker BYD Auto for its all-electric compact car launched in China this year. Addressing the rising cost. The UK also has a lot of research and investment in battery technology. £10 million in Faraday Battery Challenge funding is being used to build a better UK battery industry. Projects include a consortium led by Lena Energy that will develop a new sodium nickel chloride battery system that will improve battery performance and optimize manufacturing for scale-up, decarbonization and recycling. The other, led by Anafite, aims to develop faster charging batteries by incorporating graphene into the battery cathode. Funding from the Faraday Battery Challenge also helped open the UK Battery Industrialisation Centre in Coventry last year. The centre aims to support UK industry in developing battery technology for future electrification. In addition to cost and performance, new battery technologies also focus on sustainability issues. There are a lot of people saying that when electric vehicle batteries are no longer suitable for use in vehicles, they can get a second life in functions like grid storage, but there will also be a point where they will degrade too much to be useful in this application. It's clear that one should only be investigating and researching new technologies where the recycling at end of life can be achieved in a green way, says Thomas. It's not green recycling just to shred the batteries into black powder and then send it to be incinerated or buried in China, which is currently what the industry is doing. We have a finite supply of materials in the world and, therefore, we should be doing our utmost to recover these precious elements at a battery's end of life. However, the process is a complicated one, says Thomas. Batteries do not end life in the same state as they started it, she adds. If all we had to do was dismantle a pristine battery, that might be something that would be a very surmountable problem. But these end-of-life batteries will actually have been abused in terms of maybe being driven beyond the recommended life or treated in ways by the average motorist that are not exactly the optimum way of treating the battery according to the technical guides. Every battery is a new case in terms of recycling. A project for researchers is around how the whole life cycle of a battery can be monitored. The data collected will tell the end-of-life recycler what that battery had gone through and will inform them how that particular unit can be safely taken apart and the elements recovered. Resource management company Veolia last month announced plans to build its first battery recycling plant in the UK, which it says will have the capacity to process 20% of the country's waste electric vehicle batteries by 2025. Veolia estimates that by 2040 there will be 350,000 tons of used electric vehicle batteries in the country. The Minworth plant in the West Midlands will first discharge and dismantle the batteries before completing the recycling process for mechanical and chemical separation. One positive factor for researchers looking at how to efficiently recycle electric vehicle batteries is that the need to find solutions is not as urgent as developing future battery technology. We've got a little bit of time on our side, says Nicholson. The reality is there are not enough batteries that have been into a car, been through their useful first life and come out again to support recycling plants on an economically viable basis. That's useful because we need the technology to mature a little bit. Addressing the rising cost. Scientists at the University of Michigan have developed a biomimetic membrane that could increase the charging capacity of electric vehicle batteries by 5 times and significantly increase their range. Lithium-sulfur battery technology is seen as a potential future car battery chemistry with 5 times the charging capacity of industry-standard lithium-ion batteries. However, the cathodes used therein are inherently unstable, with a 78% dimensional change with each charge cycle, which means they are impractical for use in consumer electronics. The failure also causes them to degrade extremely quickly, meaning they need to be replaced more frequently than lithium-ion batteries. But a solution is coming. There are a number of reports claiming several hundred cycles for lithium-sulfur batteries, but it is achieved at the expense of other parameters: capacity, charging rate, resilience and safety, says Nicholas Kotov, a professor of chemical sciences and engineering at the university, who led the research. The challenge is to make a battery that increases the cycling rate from the former 10 cycles to hundreds of cycles and satisfies multiple other requirements, including cost. The scientists used recycled Kevlar, the same material found in bulletproof vests, to create a network of nanofibers similar to cell membranes. This addresses many of the fundamental problems of degradation and instability in lithium-sulfur batteries. Kotov described the new design as almost perfect, bringing capacity and efficiency close to the theoretical limits of lithium-sulfur batteries. A life expectancy of 1,000 cycles means that the average car battery needs to be replaced about every 10 years. In addition, the materials used in production are more common and less polluting than those used in lithium-ion batteries. Please give Electric Vehicle News Bitesize podcast a 5-star review to help us grow our audience. Subscribe to the Electric Vehicle News Bitesize podcast for free on Apple Podcasts, Google Podcasts, Overcast, Deezer, Breaker, Castbox, Pocket Casts, Radio Public, Stitcher, Amazon Music, Audible, Gaana, Samsung Podcasts, Google News and the Electric Vehicle News Bitesize Alexa skill. For more articles and episodes, search Hyundai confirms European launch of affordable electric vehicle. Subscribe to Electric Vehicle News Bitesize podcast for free.